Okay, so we're continuing to look at our exponent rules. Now we're going to be looking at some division problems. So the first example we have here says x to the power of 5 divided by x to the power of 3. So let's figure out what the rule is again by first breaking down our terms. So x to the power of 5, remember, is simply x multiplied 5 times. So x times x times x times x times x. And then on the bottom we have x to the power of 3, so that's x multiplied 3 times. X times x times x. Okay, so let me move out of your way here. So now we just need to remember, what is it when you divide x divided by x? What's the result? If you said x divided by x equals x, then you are one of many students who make the same mistake. X divided by x does not equal x. What does 5 divided by 5 equal? 1. And a million divided by a million is 1. Anything divided by itself is 1. So whatever x is, when you divide x by itself, you're going to get 1. So x divided by x is simply going to equal 1. So I can cross that out and rewrite it as simply 1. And then x divided by x again is going to equal 1. And then this x divided by this x also equals 1. So what we have left now is 1 times 1 times 1. Let me write this out. 1 times 1 times 1 times x times x. Okay, you follow that? Because what we said was x divided by x, whatever x is, let's suppose x is 5. Then it's 5 divided by 5, that equals 1. Anything divided by itself is always 1. So x divided by x is 1. X divided by x again is 1. X divided by x is 1 again. And so, in a sense, these x's are canceling each other out. And we're left with the two x's that were on top at the right. So we have 1 times 1 times 1 times x times x. Well, remember, when you multiply by 1, it doesn't have any impact. If I have 5 and I multiply by 1, I have 5 still. Anything times 1 is itself. So 1 times 1 times 1 times x is simply x times x, which can be rewritten as x squared. All right, so again, let's look at our original problem now. And what we want to do is come up with a rule that we can use so that we don't have to go through all the trouble of working all this out. What could we have done right away at the beginning with our exponents to arrive at our answer, x squared? Well, if you think about it, it shouldn't take you too long to realize 5 minus 3 equals 2. So just like in our last video, when we multiplied the bases, we added the exponents. When we divide bases that are the same, we're going to subtract the exponents. So that's our quotient rule. Quotient simply means divide. When you, let me move out of your way here, when you divide same bases, you subtract their exponents. So let's look at a few more examples. 10m to the power of 11 divided by 5m to the power of 2. Again, we're not going to subtract the coefficients. We're going to divide them. This is just 10 divided by 5 like you've done since you were in elementary school. 10 divided by 5 is 2. And then, since we have a base of m, we're going to write down our base. That's the base. And what are we going to do with our exponents? Well, since we're dividing, we're going to subtract the exponents. 11 minus 2 equals 9. And that's your simplified answer. 2m to the power of 9. Alright, example number 3 says 12a to the power of 3, b to the power of 7, c to the power of 5, divided by 4ab to the power of 6, c to the power of 2, d. This looks really tricky, but again, just apply the rule, the quotient rule, step by step, and we shouldn't have any problem. Start by dividing your coefficients. 12 divided by 4 equals 3. Here. My first base is a. So I'm going to write down an a. And then I'm simply going to subtract the exponents. Well, we have a 3 for the exponent on top, and the exponent on bottom, you don't see an exponent, so it has to be an invisible 1. So we put the 1 down and simply subtract. 3 minus 1 equals 2. Get out of your way here. The next base is b, so write down the b. Subtract the exponents. 7 minus 6 and that equals 1. So we can write b to the 1, or you can just leave the 1 out. It can be invisible if you want. Next base is c, so we write down a c, subtract the exponents. 5 minus 2 equals 3. And then the last term, the last base is a d. Notice there's no d's on top, just 1 on the bottom. So there's nothing to do with it. Just leave it alone, keep it on the bottom, and there's your final answer. 3a squared b. Normally you would not even write this 1 here. 3a squared b, c to the third over d. All right, your turn. Again, I'm going to give you one more problem. I would suggest that you pause the video after I give it to you. Try it on your own. See if you can work it out, and then press play to check your answer. If you get stuck, that's okay. Just play the video and see how I work it out, and you should hopefully have your question answered then. All right, go ahead and take a stab at it. Pause the video and try it on your own, and then press play to check your answer. Okay, so again, we're dividing. So we're just going to start out by dividing the coefficients. Negative 15 divided by 3 is negative 5. We're going to subtract the exponents for the same basis. So our first base is x. Write down the x. Subtract the exponents. 9 minus 4 equals 5. Write down your next base. We have a y to the third on top, but there's no y's on the bottom. So just write down y to the third. You don't have to even do anything. And then your last base is a z. So you write down your z. Subtract the exponents. 12 minus 11 equals 1. You could write down the 1, but you can keep it invisible. And there you have it. That's your simplified answer.